Hello everyone, you're welcome to provide a solution given this nice algebra problem, which is 3 to power t plus 2 to power t. This is equal to 35. So what is the value of t? And given that t is greater than 0. Now solution from here, we have that 3 to power t plus 2 to power t, this is equal to 35. We can express 3 to power t as 3 to power t raised to power 1, which is the same thing, plus 2 to power t raised to power 1, which is the same thing as 2 to power t. This is equal to 35. The next step here, now we can express 1 as 3 divided by 3. So substituting this here, we will have 3 to power t raised to power 3 over 3 plus 2 to power t raised to power 3 divided by 3. This is equal to 35. Now we have that a to power n raised to power m. This can be expressed as a to power n multiplied by m. Applying this indices identity, we'll have 3 to power t divided by 3 raised to power 3 plus 2 to power t divided by 3 raised to power 3. This is equal to 35. The next step here, we say let 3 raised to power t over 3 be equal to a, and 2 to power t divided by 3, this be given as b. Substituting a and b in this equation, we'll have a to power 3, we'll have a to power 3 here, plus b to power 3, this is equal to 35. Now the next step here, we have, this is the sum of two cubes, so we have a cubed plus b cubed, which we can express as a plus b, a squared minus ab plus b squared. Now here we have a cubed plus b cubed, this is equal to 35. Now this is the sum of two cubes, that is a cubed plus b cubed. This can be expressed as a plus b, a squared minus ab plus b squared. Now in this case, we have a plus b, a squared minus ab plus b squared. This is equal to 35. The next step from here, we find that a squared minus ab plus b squared, this is greater than a plus b. Okay, this is the condition that we need to satisfy. And in this case, given that a plus b, a squared minus ab plus b squared, this is equal to 35. So let's get the factors of 35 here. We have 35 multiplied by 1. We have 1 times 35 here. We have 5 times 7. And then we have 7 times 5. And given that a plus b, that is a squared minus ab plus b squared is greater than a plus b. So from what we have here, that 5 times 1, this does not satisfy the condition. 1 times 35, this satisfies. Then 5 times 7, also this satisfies. But 7 times 5, this does not satisfy the condition. So let's start with either case one. Okay, so let's start with 5 times 7 here. So here we have a plus b, a squared minus ab plus b squared. This is equal to 5 times 7. So in this case, we have a plus b this is equal to 5. And we have a squared minus ab plus b squared, this is equal to 7. So now from what we have here, a plus b equal to 5, that is a plus b equal to 5. Now we need to form this system, this linear equation here, which is a squared minus ab plus b squared is equal to 7. So what we do here, let's square both sides here, so that now a plus b squared, a plus b squared, this is the same thing as a squared plus 2ab plus b squared. Okay, now this is equal to 5 squared, which is equal to 25. So now we have a squared plus 2ab plus b squared, this is equal to 25. And given that we have a squared here minus ab plus b squared, this is equal to 7. Now we have two systems of linear equations here. So let's subtract these two equations here. Let's subtract these two equations. So here we have a squared, subtract a squared, this simplifies. Then we have 2ab, subtract negative ab, this becomes 3ab. Then b squared, subtract b squared, this is actually equal to 0. And here we have 25, subtract 7, this is equal to 18. So now here we have 3ab, this is equal to 18. So let's divide here by 3. So from what we have here, AB is equal to 6. Okay, AB is equal to 6. So let's proceed from here. Now, given that now here we have a times b, this is equal to 6. And given that a plus b is equal to 5, we can make b to be the subject of the formula, so that b will be equal to 5, subtract a. Okay, so let's substitute this. So we have a times b, and b is 5 subtract a, this is equal to 6. Now we'll have a times 5 here, so this is 5a, subtract a times minus a, this is a squared, this is equal to 6. So let's rearrange this equation. We'll have negative a squared plus 5a, let's take 6 on the left hand side, so this is minus 6, this is equal to 0. Let's multiply both sides by negative 1, so that negative 1 times minus a squared, this is a squared, subtract 5a plus 6, this is equal to 0. Now this is the quadratic equation. This is the quadratic equation where a is equal to 1, b equal to negative 5, and c equal to 6. So in this case, we have a1, okay, a2 equal to minus b plus or minus the square root of b squared minus 4ac divided by 2 times a. So here, substituting the values of a, b, and c, we'll have minus 5 plus or minus the square root of b squared, in this case is minus 5 squared, subtract 4 times a, which is 1, times c, which is actually equal to 6, all this divided by 2 times a, which is 1. So here we'll have minus times minus 5, this is 5, plus or minus the square root of negative 5 squared, this is 25, subtract 6 times 4, this is 24, divided by 2. So in this case, we'll have 5 plus or minus, now the square root of 25 minus 24, this is 1, divided by 2. So here we have 5 plus or minus the square root of 1, this is 1, divided by 2. So here we have that a1 is equal to 5 plus 1 divided by 2, and this is equal to 6 divided by 2, and this is equal to 3. Now we have a2 equal to 5 subtract 1 divided by 2, and this is equal to 4 divided by 2. A2 is equal to 5 subtract 1 divided by 2, which is 4 divided by 2, and therefore a2 is equal to 2. So we have a1, a2, this is equal to 3 and 2. So we have two values of a1 and a2. So let's solve for b1 and b2. Now, if you recall here, we end that a plus b, this is equal to 5. So substituting the value of a1 here is equal to 3. So let's substitute here. So we have 3 plus b, this is equal to 5. Therefore b is equal to 5, subtract 3, and therefore b is equal to 2. So in this case, a1, comma b1, this is equal to 3, 2. This is the first set of solution here. This is the first set of solution. The second set of solution here, we have that a plus b, this is equal to 5, and given that a2 is equal to 2, let's substitute here. So b is equal to 5, subtract 2, and therefore b is equal to 3. And therefore, a2, comma b2, this is equal to 2, 3. So this is the next set of solution. Now, given that a1, b1 is equal to 3 and 2, and at a2, b2 is equal to 2, 3. Now, if you recall, we are saying that let 3 to power t divided by 3 be equal to a, and 2 to power t divided by 3 be equal to b. So let's compare here a1 and b1 in this case, which is 3 to power t over 3. This is equal to a, which is equal to 3. And in this case, you can see that the bases are common here. So this is 3 to power 1. Since the bases are common, given that a to power m, this is equal to a to power n. So applying this exponent property, then since the bases are common, then m is equal to n. So applying this exponent property here, so it follows that t over 3, this is equal to 1. So now to solve for t, let's multiply both sides by 3, so that t here is equal to 3. T is equal to 3. Now let's solve for 2. We have that 2 raised to power t divided by 3. This is equal to 2. And 2 is raised to power 1. Applying this exponent property, it follows also that t divided by 3, this is equal to 1. We multiply both sides by 3. And this also clarifies that t is equal to 3. So t is equal to 3 in the first case. So let's check a2, b2. Now we have that 3 to power t divided by 3 is equal to a2 here is 2. So you can see that the bases are not equal, are not the same. So we reject this. And on the second part, we have 2 raised to power t over 3. This is equal to 3. The bases are not common, so we reject this. So the only solution here is t is equal to 3. So let's verify here. Let's verify. We have that 3 to power t plus 2 to power t. This should give us a value of 35. Substituting the value of t here, we'll have 3 to power 3 plus 2 to power 3, this should give us a value of 35. So 3 to power 3, this is 27, plus 2 to power 3, this is 8. This should give us a value of 35. So 27 plus 8, this is 35. And that shows that the left-hand side is equal to the right-hand side. And that affirms that the value of t, which is equal to 3, actually satisfies the equation. So kindly follow the steps, like this video, and subscribe. See you in the next video. Bye bye.